Okay, guys, so today we are going to talk about volume and Cavalieri's principle. So we'll start off first with Cavalieri's principle. The whole premise of Cavalieri's principle is this. If you have two parallel planes, now parallel planes is just a fancy word for height. So if you have two parallel planes that cross the same, that create cross sections that are the same area, then the volumes are the same. So in this image up here, we have a rectangular prism, we have a tilted rectangular prism, and we have a cylinder. Because at each of these plane levels, these cross-section areas are the same, we know the volume is the same. Guaranteed, if you see parallel, cross-section, and area in a question, it is going to have the same value. That's Cavalieri's principle. Now, even look here. Here we have three pyramids. This one's got a triangular base, this one has a square base, and this one has a polygon base. However, because this says area 6.8, area 6.8, area 6.8, we know that the volumes of each of those pieces are the same. So let's take a look at something related. Here it says a circular garden has a diameter of 12 feet. How many bags of topsoil must Linda buy to cover the garden if one bag covers an area of 3 square feet? Well, this is when you're going to look at the formula sheet, and on the formula sheet, you will see that the area equals pi r squared. Now, our issue here is that they tell us the diameter. And so because they tell us the diameter of this circular garden, we can't plug it into the equation right away. I told you in the past that anytime you see diameter, immediately I want you to write r and whatever the radius equals. So here, since the diameter is 12, we know our radius is 6. So now I've got, well, here's my area equals, I am going to actually use 3.14 for pi simply because I don't have pi in any of my answers, times 6 squared. Okay, then we're going to get a calculator. We know that 6 squared is 36. So I'm going to do 36 times 3.14, and we get 113.04. So now we know that that is the area of our garden. But look at, that's not one of these answers. So some of you might be like, oh, let me just put 151. Maybe I did something wrong. The issue is that now we have to figure out the number of bags because it's asking us how many bags of topsoil we need. So because one bag covers 3 square feet, you could either set up a proportion, which is the long way, 1 bag over 3 feet. This is an A, equals x over, nope, yeah, x over 113 feet, 0.04 feet. So you could set a proportion, and we're going to look at other proportions coming up, and you could cross multiply. The other thing that you could do is just take this and divide it by 3, which is how I would do it. So when I do that divided by 3, I get 37.68. Now the issue is that 37.68 is not one of the choices, and it makes sense because we're going to need 37 full bags plus that additional 0.68, and it's not like you can go to Walmart or Home Depot and get 0.68 of a bag. So that's why it says 38. They might try to trick you, and they might give you an answer of 37 or 38. So just make sure that if they do try to trick you, you always will round up. All right, here's our next one. Now it says 2 stacks of 23 quarters each are shown below. One stack forms a cylinder, but the other stack does not form a cylinder. Use Cavalieri's principle to explain why the volumes are the same. Well, I'm not going to write a whole lot, but we know that the height has to be the same. We know the height is the same because it says that each quarter, there's 23 quarters in each stack. So we know the height has to be the same. We also know that they're each quarters. So quarters, because, you know, made by the U.S. Mint, they have the same area. So because of that, and it would be nicer if you wrote cross-sectional area, but I'm not going to do that. So because of that, you can easily say that because the stacks of quarters are the same, because each quarter has consistent area or cross-sectional area at each level, it's a quarter. It's not like all of a sudden there was a dime. That's why the volumes are the same. Am I going too fast? Use Cavalieri's principle to decide which of the figures described below have the same volume. as an oblique cone with base radius 3 and height equals 12. Bottom line here is that you have a, I guess we have to look at it. So the radius, it tells us, is 3 and the height is 12, and we're looking at a cone. So the formula for a cone is on your formula sheet. And it is, let me just look it up, 1/3 pi r squared height. So when we put that in, we have 1/3 pi. We're first figuring out the cone. Our radius they gave us was 3, and our height is 12. So when we do that, we have 1/3, 3, 12, 36 pi. It ends up becoming 36 pi. So let's see, a cylinder with a base diameter of 6 and a height of 12. The issue is do you see how our answer has pi in it? Because this doesn't have pi in it, we know it really can't be choice A, because pi is just one of those unique 3.14 numbers. Same thing for B. It can't be B because, oh wait, it could be B because B says a cone. Hold on. It might be B. Let's look at B. B says a right cone with a radius. No, it can't. Yeah, well, let's look. Here's choice B. This is me Russian. I'm sorry. So area of a cone, again, or volume of a cone is 1/3 pi r squared height. Now we're going to put in, here's my r, 1/3. Here's our pi. This time our radius is 6 squared, and our height is 6. So when we do that on the calculator, 36 times 6 is 216, divided by 3 gives us 72 pi. So it can't be choice B because we're trying to get 36 pi. Choice C, a pyramid with a base area of 9 pi and a height of 12. So if we look at the formula, this is for choice C, of a pyramid, it's 1/3 times the base, which is the base area, and the height. So I'm going to do 1/3. The base, they tell us, is 9 pi, and the height is 12. So we're going to do 9 times 12 first. Gives us 108, divided by 3, gives us 36 pi. So our answer is choice C. So even though it doesn't make sense that you would have pi in a pyramid, because that base area included pi, that's how we know that that's our correct answer. Okay, next, here's some things about cylinders real quick. When we have a cylinder in cross-sectional areas, you will need to know this information. I guess my head's just kind of floating up there. Some things for cylinders. If you do it directly across, you'll get the circle. You'll get the same thing that's on the base. If you do it directly up and down, that's perpendicular, you'll get the rectangle. That's what this is. Now, see how this one's at an angle? Because it's at an angle, it ends up being an ellipse or an oval. So oftentimes we remember the circle or the square, but we forget the ellipse for the diagonal cut. For a cone, these are some things you will not likely see the parabola as a choice, but if you cut a cone at a tilt, you'll get a parabola. If that tilt has part of it at the base of the cone. If you do directly perpendicular to or parallel to the floor, you could get a circle. If you do it perpendicular to the floor, that's where you get your triangle. And then if you do it at an angle, that's where you get your oval. And I am confident you will see a cross-section question on the test because that's one of the fundamental beliefs in geometry. Pyramids down here, straight up and down. If you do it through the tip, that gives you the triangle. Straight across gives you the square or whatever the base is. So if the base is a rectangle, then you would get a rectangle. The pyramid goes from one side down to the middle. Now, that's how you'll get the trapezoid. One thing to think about that I learned recently about cross sections is it's atypical. I haven't seen an example where, let's say the cross section is like you're doing the cross section of a cube. You wouldn't get like a 12-sided figure as a cross section in a cube. Like that wouldn't make sense. So or you wouldn't have like a 12-sided cross section and then not have one that's like 6 sides. I don't think that made sense, but you'll see coming up. Here's a sphere. Spheres are basically just circles when you cut it. So you can get circles and ellipses if you have cross sections of spheres. And then here's some things for the cube that I didn't know until I looked it up. We all remember the base is the square, but I forgot that if you have a cube and you do the diagonal, you can get a rectangle. If you do just the corner of a cube, you can get a triangle. If you go from the top side down to the bottom side, you actually get a trapezoid. And this one's kind of tricky to see. If you connect the midpoints of the opposite sides of the cube, you actually, and I had no idea this was true, but can get a hexagon. So I think when I taught you the first time, I pretty much just taught you parallel and perpendicular and kind of diagonal, but I didn't show you these where like you would either cut the corners or connect the midpoints. So next. All right, let's do some more questions. A two-dimensional cross-section is taken of a three-dimensional object. If this cross-section is a triangle, which cannot be this three-dimensional object. Well, we know the cone looks like this, so it can't be the cone. And then we know that the pyramid also has a triangle in it. So we're between the cylinder and the rectangular prism. This is when it goes back to this part right here. If you actually can get a triangle from the rectangular prism if you cut the corner. So that's something I had not taught you before. So it won't be rectangular prism because we could cut the corner. So our answer is 2, cylinder. Volume 5. A cross-section of a rectangular pyramid contains the altitude of the pyramid. All the altitude means is that it goes through the top point. The shape of this cross-section is a triangle because it goes through the point. If it didn't go through the point, remember that we showed you over here, if it didn't go through the point, then it would end up being this trapezoid. But because the cross-section goes through the point, it includes the altitude. That's why we know it's a triangle. The length of the side of a cube is 7x, which expression represents the cube's volume. This is actually trying to confuse you. So here's our 7x. Here's the wrong way, is just putting a 3 up here. When you put the 3, the formula says for a cube that you actually have to multiply base times height. And then also in base, it stands for the length times the width. So you actually have to put the 7x in parentheses. So this is really saying 7 cubed times x cubed. So your answer will be choice 4. Because 7 times 7 is 49, times 7 again will give you 343. And then you have the x cubed. A fish tank has a rectangular base. It has a volume of 3,360. So we know that our volume is this. And this is a good example of a DOK2 question because we're actually working backwards. So they gave us the volume. We know that it's got the rectangular base, so we know that volume is length times width times height. So we can put in 3,360 equals, well, the length and width are 14 and 12. We just have to determine the height. So we're going to do order of operations. We got to simplify that side first. 14 times 12. So this gives us 168h equals 3,360. And then we're going to divide both sides by 168. And that gives us 20. So 20 inches is the height. Still see writing, I'll give it a second. Okay, next question. A company is creating an object from a wooden cube with an edge length of 8.5. So because it's a cube, we know that the length, width, and height each equal 8.5. A rectangular cone with a diameter of 8. So remember, anytime we see diameter, we immediately write the radius value, so we don't put 8 in by accident. So radius of 4. And an altitude of 8 will be cut, which expression represents. So basically all you're doing is you're taking a cube and you're subtracting, oh, and it says the remaining wood. So you're going to take the cube and you're going to subtract the cone. So we know that 8.5 cubed is going to be our starting point, which makes sense because look at all these answers have 8.5 cubed. It says cone, so if we look at our formula sheet, we know that the formula is 1/3 pi r squared height. So we can eliminate 1 and 2 and not even consider them because they don't have 1/3 in them. So now we're going to look here. Well, the only difference between choice 3 and choice 4 is this 8 and 4. And because you guys got in the habit of as soon as you see diameter, you write that radius value, that's why we know it's going to be choice 4. So it is possible that you'll see a question like this simply because it challenges your brain. It looks a little confusing. So it's, can you manipulate multiple formulas and come up with a solution? If they asked you just for like what was removed, then you would only do this. But because it says what was left, you needed to find the whole cube first and then subtract the remaining pieces. The Great Pyramid of Giza, anyone know, was constructed as a regular pyramid with a square base. So that helps us out right there. We know it's a square on the bottom. It was built with approximate volume of this huge number. So right away, I'm going to look on my formula sheet for the volume of a pyramid, which is 1/3 base times height. So I know I'm going to have 2,592,276 has to equal 1/3. Now it tells us our height, but we don't know our base. So I'm just going to put x for our base, and we know our height is 146.5. So we basically just have a lot to do with the calculator. Because this is 1/3, usually what you would do is multiply both sides by 3 to get rid of the 1/3. I say just simplify it. Type in 146.5 divided by 3, and that's going to give us 48.83. And then we have our x. Now, I'm not going to write all this again, but that would also go there. So now all we're going to do is take 2,592,276 and divide it by 48.83 so that we can isolate the variable and get x all by itself. Okay, so I'm going to type it in the calculator, 2,592,276 divided by 48.83. Oops, I did something wrong. Oh, no, I didn't. Okay, so then when we do that, we end up getting 53,087. And that equals x. But remember, x was our whole base. So now, because it's a square, we know that area of a square is side squared. So all we need to do is now we take this, and then we're going to take the square root of both sides, and that's going to give us our x value. Because what that told us, that number represented if I shaded all this part in. But we only want one side, so that's why we took the square root of this whole number, and that's how we got 230. Okay, so we're going to end this recording right there.